Stress analysis of simply supported beam. Welcome to the next generation learning. Quality education is my birthright. Now let us consider a simply supported beam. Which is subjected to a load of 20 kN at the midspan. The properties of the beam are as shown. Now let us go to preferences, structural, preprocessor, element type, add. Now let us select the beam to node 188, OK, close. Go to the material properties, material model, structural, linear, elastic, isotropic. Here we add the Young's modulus, that is Ex, and PRXY, that is Poisson's ratio. Now let us go to section. Here we define the section of the beam. As we have seen earlier, the B and H values are 200 and 300 mm. We have entered the section. Now let us go to modeling to create the key points. Here we create the key points and then join the key points using the lines to create the elements. As we have created the 3 key points, now we are going to lines, straight lines. We are joining the lines to create the elements. Now once the lines are created, we need to divide this line into finite number of parts, that is meshing. So we are dividing each element into 100 divisions, that is 1 to 2 is divided into 100 divisions and 2 to 3 is divided into 100 divisions. Now we are meshing it. Now to apply the boundary condition, we go to structural, displacement, then on key points. Select the first key point. This is the method to apply the boundary conditions for the simply supported beam. Now we'll pick the random and it will pick the mid node. Now let us enter the Fy value, that is minus 20,000. It is shown in the negative y direction. Now let us solve this. We can see the deformed shape. Now go to element table, add by sequence number SMIC. Now enter the value of 6, 19, 3 and 16. These are the combinations that we need to remember for obtaining shear force and bending moment diagrams for beam 2 node 180. So for different beam elements, this combination varies. Go to plot, contour plot, line element result 6 and 19. Now we can see the shear force diagram. To see the bending moment diagram, use the combination 3 and 16. You can see the bending moment diagram. And to watch the animation, we can go to plot control and animate it. Here we can see the animation, and to see the 3D view, we can click on isometric. Thanks for